All right, so what we're going to do today is we're going to be covering inverse functions. So it says make a table of values for graph A. So I already highlighted graph A in pink. So let's go ahead and write the table. So on here, -2 goes with 1, 2, 3, 4. And then -1 goes with -2. 0 goes with 1, 2, 3, 4. 1 goes with -2, and then 2 goes with 4. All right. So now from there, we're going to go ahead and, this is a -4. Make table B. So complete table B by reversing the order pairs on table A and graph the resulting relation. So all we're doing is flip-flopping. So this is going to be 4, -2, -4, -2, and 4. And then we're going to take the x values. So our x values were -2, -1, 0, 1, and 2. And we're going to go ahead and graph table B. So 4 goes with -2. So 1, 2, 3, 4, -2. -2, -1. -4. 0, 1, 2, 3, 4, 0. Oops, this one should be. I forgot how to graph. Sorry. This is something like weird. -2, -1. There you go. I forgot how to graph points for 2 seconds. All right, and then -4, 0, -2, 1, and 4, 2. There you go. And that's what your graph looks like. All right, so if you can tell, it says, does graph A represent a function? So the way that you can tell if A is a function by doing the vertical line test and checking to see if it's a function. So that means that nowhere should it cross more than once. That's a vertical line. And so graph A, yes, it passes the vertical line test. But graph B, if I make this vertical line here, do you see how it crosses more than once? So does graph B represent a function? No, it does not. Okay. All right. So here it tells you make a table of values for graph A. Complete the table B by reversing the order pairs on table A. So table B and A. So let's go ahead and make the values for A. So -2 goes with 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. -2 goes with 8. -1 goes with 1, 2, 3, 4. 0 goes with 2. 1 goes with 1, and 2 goes with, it looks like 0.5. So now to make table B, we reverse the order. So we have 8, 4, 2, 1, and 0.5. And then our x values are -2, -1, 0, 1, and 2. So on here, we're going to do 8, -2. So 1, 2, 3, 4, 5, 6, 7, 8, -2. 4, 1, 2, 3, 4, -1. 2, 1, 2, and 0, 1, 1, and 0.5 and 2. So if we connect those, this is what it looks like. So if you notice on both of these graphs, they are cut in half by this line here. This is our line of symmetry. So it's a y equal to x line, and it cuts it into 2 equal parts. So it's perfectly symmetric about that line. And so that's what makes them inverse functions. They're opposite of each other, and you can tell on the graph because they are cut in half by that line. You can tell in the table because these numbers are in the reverse order. So now, does graph A represent a function? So if we do the vertical line test, it most definitely passes the vertical line test. So yes. And does graph B represent a function? Yes, it also represents a function because it passes the vertical line test. Okay, remember, for it not to be a function, you'll have 2 x values, and it's 2 of the same x values. So next it says the tables and the graphs on examples 1 and 2 show inverse relations. All inverse relations have the following characteristics. The independent and dependent values are interchanged, and the graph has a reflection over the y equal to x. That's what I just explained right now. So if the inverse relation of a function is also a function, like on example number 2, then the relation is called the inverse function. The inverse function of f of x is represented with the notation f inverse of x. So this little -1 here, that means that's the inverse function. Now we're going to find the inverse functions through the equation. So these are the 4 steps that you have to follow. Your first step is to replace f of x with y. Then you're going to switch x and y. And then you're going to solve for y. And then you're just going to replace y with f inverse of x. Okay, so it seems a little bit complicated, but don't worry. I'm going to walk you guys through it. So the first step is to replace f of x with y. So here, instead of f of x, I'm going to write y equals 2x to the 3rd power plus 3. Okay, then step number 2, we are going to switch x and y. So it's going to rewrite as x equals 2 times y to the 3rd power plus 3. Okay. Step 3, we're going to solve for y. So that's going to take a few more steps. So we're going to get the y by itself. So first we need to get rid of this 3 by subtracting on both sides. Okay. We get x minus 3 equals 2y to the 3rd power. Okay, the next step is to get rid of this 2 that's with the y, because we're still trying to get the y by itself, so we need to divide both sides by 2. So we get x minus 3 over 2 equals y to the 3rd power. Then our last step to get the inverse function, or to get the y by itself, is to get rid of this cubed. So the opposite of cubed is the cubed root. So what you do to one side, you have to do to the other side, and you have to do it for the whole side. So we're going to take the cube root of the whole thing. So we end up getting y equals the cube root of x minus 3 over 2. So then our last step is to replace y with f inverse of x. So that's what I'm going to do here. Instead of y, we're going to replace it with f inverse of x. So this is saying the inverse function of this one is the cube root of x minus 3 over 2. Okay, so if you didn't understand that time, we are going to do this 3 more times. All right. So step 1, replace f of x with y. So here's f of x. Instead of f of x, I'm going to write it as y equals 1 over x minus 2. The second step, switch x and y. So we're going to get x equals 1 over y minus 2. Okay, step 3, solve for y. So we need to get the y by itself. So we're going to do that first by getting rid of this minus 2 and adding 2 on both sides. So this cancels, and I get x plus 2 equals 1 over y. All right, our next step, we have the y on the bottom. We can't have it on the bottom. It needs to be on the top. So we need to get rid of this fraction 1 over y. So what we're going to do is we are going to flip it. So instead of being 1 over y, we're going to flip it over y over 1. But if we flip it, we also have to flip the x plus 2. So instead of the x plus 2 being on the top, we're going to have to move it to the bottom. Okay, so all I did was just flip it over. Okay, now on the top, since there's nothing up there, you have to fill it in with the 1. Okay, then from there, I believe that's it. Y divided by 1 is just y. And then our last step is to replace y with f inverse of x. So we're going to rewrite it as f inverse of x is equal to 1 over x plus 2. Okay, and that's it. All right. The next section. So here we have f of x of 3x to the power of negative 2/3. So we start doing the exact same steps. Our first step is to replace f of x with y. So we're going to write it as y equals 3x to the power of negative 2/3. Step 2, switch x and y. So it's going to write it as x equals 3 times y to the power of negative 2/3. Okay. Step 3, we're going to solve for y. So I'm going to get the y by itself. So before I do anything, I need to get rid of this negative 2/3. So the way that we get rid of it is by putting all of this to the power of the reciprocal, 3/2. And not just 3/2, we need to cancel out the negative also, and we know two negatives make a positive. Okay. Now, what we do to one side, we have to do to the other side. So I also have to put this to the power of negative 3/2. So we get x to the power of negative 3/2 equals 3y. These cancel out because two negatives make a positive, and then 2/3 and 3/2 cancel each other out. So we're just left with 3y. Then our last step to solve for y is to divide both sides by 3. So we get x to the power of negative 3/2 divided by 3 is equal to, and now we're left with the y by itself. Then from there, our last step is to replace y with f inverse of x. So we're going to rewrite it as f inverse of x is equal to x to the power of negative 3/2 over 3. And that's it. All right, number 6. We do the exact same thing. Step 1, replace f of x with y. So y equals 2 times the cube root of x. All right. Step 2, switch x and y. So this is going to be x equals 2 times the cube root of x. Then we are going to start solving for y. So we're going to get the, I wrote x twice. This should be y. Now we're going to start solving for y. So we need to get the y by itself. So we are going to first get rid of the 2. So we're going to do the opposite and divide because it's being multiplied times the square root. That cancels, and we get x over 2 equals the cube root of y. Okay. Next, to get the y by itself, we need to cancel out the cube root. So we do the opposite of the cube root, which is cubed. So what we do to one side, we have to do to the other side. And so on here, we get x over 2 to the 3rd power equals the cube root and the cube cancel. This gives us y. Now this can be written 2 different ways. We can distribute the cube to each one and get x to the 3rd power, 2 to the 3rd power, which would simplify to x to the 3rd power, and then 2 times 2 times 2 gives you 8. Is equal to y. So either answer is correct. I believe on Delta Math they both work, but if it's multiple choice, you're going to go with this answer. Okay. Then our last step, replace y with f inverse. So f inverse of x equals the cube root over 8. And that's it. All right, now we're going to go into the graphing section. So on here, it says given f of x equals 2x minus 5, graph f inverse x on the same coordinate plane, find the equation of f inverse of x algebraically, then state the domain and range of both f of x and f inverse of x. All right, so I'm first going to go ahead and find, using the same steps, we're going to replace y equals 2x minus 5. So we replace f of x with y. Then we switch the x and the y. So x equals 2y minus 5. Then our next step is to solve for x. And we solve for y, we get the y by itself. So we get x plus 5 equals 2y. Then our last step to solve for y is to divide by 2. So we get x plus 5 over 2 equals y. And our last step is to replace y with f inverse of x. So f inverse of x equals x plus 5 over 2. All right, then from there, we're going to go ahead, and this is what goes here. F inverse of x is x plus 5 over 2. And we're going to go ahead and graph this. So here, remember, this is our point right here. This point is 0, 1, 2, 3, 4, 5. This is 0, -5. So to make the inverse, we would have to flip it. -5, 0 would be the inverse point. So 1, 2, 3, 4, 5, 0. There's the first point. This point is 2, 1. So you flip that around to 1, 2. So 1, 2 would be right here. And then this next one is 1, 2, 3, 4. 1, 2, 3. This point is 4, 3. So you flip it, 3, 4. So 1, 2, 3, 1, 2, 3, 4. And would be this point. Well, this is 2, -1. Sorry. So this one should be -1, 2. I know the point looked a little bit off. And then last is this last point. Now, you could also reflect it across if you wanted to, diagonally. So if it's 1 away, this point would end up over here. Okay, if you didn't want to do it by calling out the points. And there you go. All right. It does want us to state the domain and the range. So the domain for both functions, you can kind of see that they both spread apart in both directions. So our domain for both of them, this one's going to be from -infinity to +infinity. And so will this one, -infinity to +infinity. And then for the range, we're going to see how low does our graph go. So our graph, the lowest, you can see that it continues to go down with no gaps, all the way up with no gaps. So it's also from -infinity to +infinity. And the same here, -infinity to +infinity. All right, the next section, it says, given f of x is equal to the square root of x plus 3, graph f inverse of x on the same coordinate plane. So I'm going to show you guys how to graph it by reflecting it across, okay? So here it is 1 unit away plus a little half to this line. So you go the same distance, half, and then 1 unit, and there's the first point. I'm going to erase these lines just so it doesn't get super messy. The next one is 1.5 also, so you go half and then 1 directly diagonally. And then the next one's going to be a half away, so this is a half away. And then this next one is in the opposite direction, so it's 1.5, so half and then 1, it would be right here. So let me go ahead and erase those lines just so it doesn't look super messy. Oh, I deleted the dot. This one is here. So it'll look like this. Okay, so then it tells us to find the equation algebraically. So first, you go ahead and replace f of x with y. Then you switch the x and the y. So x equals the square root of y plus 3. Then you go ahead and start solving for f for y. You get the y by itself. So on here, the square root of y plus 3 is in the square root, so you need to get rid of the square root first. Now what you do to one side, you have to do to the other side. So we get x squared equals y plus 3, because the square root and the squared cancel each other out. And then we're going to, I'm going to rewrite up here. X squared equals y plus 3. And then we're going to go ahead and move the 3 to the other side by subtracting it. And we get x squared minus 3 equals y. These cancel each other out. And your last step is to replace y with f inverse of x. So f inverse of x equals x squared minus 3. Last, they want us to state the domain and the range. So the domain is our x value. So if we notice here on our original graph, this is where it starts, and then it continues on forever in this direction. So that number, it starts at -3, and it is a closed circle all the way up to infinity. If we look at the domain for our pink graph, it actually starts right here at 0, and then it slowly starts to spread apart. So it is going to be from 0 all the way up to infinity, okay? All right, next, we're gonna see our range. So we're gonna see how low our graph goes. So this graph right here, the lowest that it goes is 0, and then it slowly starts to go up, even though it's not spreading up super fast. It's still gonna continue to go up slowly. So that means that our range is gonna be from 0 to infinity. And then for our range, we're going to see how low our graph is for the pink function. So the lowest is 3, and then it goes up pretty quickly. So it's going to be -3 all the way to infinity. So if you notice on your inverse functions, the domain should be the same as a range, and then the range should be the same as the domain on the opposite functions. Okay, because we switched the x and the y's. All right, that's it. If you guys have any questions, please let me know. Thank you.